What's up everyone, hope you're doing well. If you're watching my video for the first time, check out the playlist to get up to date on the things I've been working on. But if you're already a subscriber, thank you. We have crossed I think like 112 subscribers at the time of making the video. So first things first, let me apologize for not making the video in the last week. I think I broke the streak after like 7 weeks, I guess. A lot of things have been happening on it. It's still going on. I thought I should skip this video for this week, but I didn't want to give a 2 weeks of gap and not give any updates. So I thought like I should just make a video on the things I'm working on and give you guys an update. So now that said, let's dive right into the video. All right. First updates, the bench testing of the flight controller showed like few things. The major one being the sensors, the IMU sensor, which is like used for measuring orientation, angular rotation, or force applied on the aircraft or like the flight controller, which is called inertial measurement unit. So there's one on board the PX4 flight controller, which is mounted on the carrier board here. The PX4 estimator needs like multiple redundant sensors for it to make an estimate correctly. So there is only one on board, but it needs like more redundant system on the drone or like the aircraft. So in general, like the flight controllers or like the this system, Autopilot system works this way. There's this carrier board, and then there's flight controller connected to it. Or in some cases, like these two would be combined into one single board. Apart from this, there is a sensor board which contains like the IMU, the barometers, magnetometers, and so on. So this board needs to be soft mounted to remove the vibrations from like the drone motors, and like the whole system of drone is like going to vibrate a lot. So the board needs to be mounted separately, connecting it with a flex cable or like a flex PCB attaching to the flight controller here. So the flight controller is already designed to have that connector. So this board and the cable is coming from a different flight controller in the market. It's from Holybro. So this is something when I was designing, or like when I was like trying to manufacture, I knew that this board needs to be designed, but I was like more concerned on getting the carrier board and flight controller manufactured. That actually I did not care, or like did not spend much time, or even like thought about like designing these unit. It's such a dumb of me to do that, but at this point, like we don't have any other option to design and get it manufactured. So I've already done the design of the flex cable and the board. It's still like some of the changes needs to be done. So that's going on, and it should be done in a week or so. That's sort of like the current update on the testing of the flight controller. All right, let's get to the build video. As you can see, the drone frame is something what we have seen in the previous videos. I'm using the same drone frame, and the motor is being connected to the ESC through a board, what I'm soldering right now. It's called motor wire extension board. So it's basically, as the name says, it extends the motor wires to the ESCs. And here it's connecting 3 wires of the motors to the 3 wires on the ESC. So I prepared like 4 of these, and it can be connected on the other side.
It was at this moment that he knew. He fucked up.
Oh my God, what did I even do? I'll tell you in the further part of the video what the problem is. Right now, let's see like connecting the motors to the wire extension board. And these motors are 2306 2450 kV motors. It's rated for 6S, 4S to 6S. These were like handed over to me by a friend of mine in New York. The frame and the motors were from him. Like I haven't used it for like almost 4 years. So as you can see, like the wires on the motors have been oxidized. So that needs to be tinned or like soldered for it to like take solder and like get attached to the pads of the extension boards. So it took me some time to like clean up the mess and do the entire process. That's why it took like an hour or like few hours to like do the entire process of soldering the motors to the ESCs. And I apologize for the mess around the table. Like there's like a lot of things going on. So I had to like get this soldered and have the drone prepared. That's the reason like it's all in a mess. Hey, mister, move over. So now moving on to the drone assembly process here. Now moving on to the complete drone frame assembly process here. Again, apologize for the camera not being in the view or like doing the assembly in the view of the camera. The drone frame required like a lot of dexterity and moving around and see over like what I'm torquing or tightening. So once the wires from the motor has been inserted into the arm and it's all like wired into the main frame, now it's the wires can be soldered to the ESCs. As you can see here, all these three motors are able to reach the ESC, but not the fourth one. That was the problem we saw like previously while cutting the wires.
3 hours later.
After a long process, I had to like rewire the fourth motor, and as you can see here in this, I did not record the two other motor wires being soldered to the ESC. And then later on the third and fourth, I realized like I haven't started recording, and as you see here, it's like the process is being continued to solder third and the fourth motors. Have fun seeing me getting struggle to get the wires into the drone frame. It took a lot of time to like get it in, and the reason being is that the wires needs to be as safe from the damages from the outside, either from the propellers or like if it's being flown in a area where the wires could get like tangled, and if it pulls down the wires, it could like damage the pad on the ESCs. So I had to like put all the wires inside the drone frame. All right, so for ESCs, 4-in-1 ESC with the motors being soldered, and now the best part, there's a challenge for you guys to identify which song is this. If you guess the song, please comment down below what it is. All right, let's move to the next stage where you need to like do the placements of all the other components. The main one being the flight controller, that's sort of like going on the top, and I'm modifying the cables to power the carrier board through a power module. And these are the wires going into the ESC to communicate between like ESC and the flight controller. And the power module connects the ESC and the battery, and also powers the carrier board. So this is more about like the placement of all the other components. I haven't connected the receiver yet, so the receiver one is going to be mounted on the front. The placement of battery is critical because that's the one which is heavier. So you need to make sure the weight of the drone is all in the center and evenly distributed, so that the center of gravity lies at the center of the drone frame. And this frame is slightly complicated design in the ways like a true X would have the center of gravity right at the center, but this is a combination of two or like 2 to 3 different frames. And the total weight is coming approximately to 530 grams. And with receiver and like a lot of wires, it should be somewhere around like 550 grams. Apart from that, I'm not placing any camera or anything. So I guess that's it. The drone frame is ready. Thanks for watching. See you in the next video.